A question. It was does a function satisfy hypothesis and mean value theorem given interval, and the function was the natural log of x on the interval 1 to 3. And I could swear that I got the value for c correct, but it was not accepting my answer. So I was wondering if you could go through that.
Yes. Yes. So. Number one, remember when you write it on paper, of course in WebAssign it's a different story, but on paper you have to write it. The function is continuous on the interval 1, 3. On 1, 3. Number two, you have to write that f is differentiable on the interval at least 1, 3. And we know that. We know from the graph. Here's 1 and here's 3. So the function is differentiable and continuous and differentiable here. So this is natural log x. And now from 1 and 2, we know that there exists a c in the open interval 1, 3 such that f prime of c equals f of 3 minus f of 1 divided by 3 minus 1 by mvt. Is this okay so far?
Yes.
Okay, perfect. So next, I find the derivative. So f prime of x is 1 over x. So in order to create this equation, I replaced on the left-hand side c, x by c. So I have 1 over c equals f of 3 is simply natural log 3. Natural log 1 is 0. And 3 minus 1 is 2. And this is a proportion. In a proportion, you can flip both sides. And that's how you get your C. And it has to be between 1 and 3. It's guaranteed. And you should always check. There is no need, but, you know. So 2 divided by natural log 3, close the parenthesis. It has to be a number between 1 and 3, and it is. It's 1.82. Is this okay, Derek?
That's the value I got, but it's not. I didn't like it.
Okay, let me get my keyboard back. And let me open WebAssign and see what is going on there. Okay.
From my 4.2, number 5.
Okay. Where am I? Okay. Okay. You said 4.2. Of course it's in 4.2 and it's number 5. Okay. Almost there. Okay, 4.2. Responses. I'm going to your responses directly. And you said, yeah, I see you entered 1.82. You're not supposed to. It says enter your answer. So you have to enter the exact value. That's why I didn't take. I see you put in 1.82. It wants 2 over natural log 3. Because 1.82 is an approximation. 2 over natural log 3 is exact.
Okay. All right. Thank you.
That's okay. Very good. Okay. Other questions? Anyone? Any questions from anything? Any questions?
Yeah, actually, I mean, if it's okay, I had another one.
Please do.
Just a moment, let me get the exact.
No one wants to talk to me but you. Is everyone else okay? Anyone? Are you guys okay? Did I upset anyone? I hope not.
I just don't want to make it seem like, I'm like taking up more time than anybody else.
Any question? We need any question. Anything helps.
Right, so for me it was a 4.3, number 6. Just how to, I didn't really know how to go about this one.
You want me to look and read it from there?
No, I can tell you it is, consider the equation, f of x is equal to 9 sine x plus 9 cosine x. And then it's asking, intervals, increasing and decreasing, local min-maxes, inflection points, and concavity.
Are we asked to graph or not?
No.
Good. Okay, very good. So, remember, I highly recommend your table, even if you're not asked, this table, even if you're not asked to graph, because it keeps everything organized and it's easier to read, but that's my opinion, it's up to you. Okay, so this function is obviously defined. Are we given an interval? Or they say?
Yes, 0 to 2 pi. Sorry.
That's okay, that's nicer, because otherwise we're going to be all over the place. Good. It's a very good example. It's going to help everyone. Okay, so are they asking us for the x and y intercepts or any of that, or just...
Right, so that asks for the intervals for increasing and decreasing, and then local min-maxes, inflection points, and...
concavity.
Concavity, yeah.
That's it. Okay, so we don't have to worry about x and y intercepts then. Good. So in that case, we just go ahead to find the first derivative, and that would be a 9 cosine x minus 9 sine x. There are no critical numbers coming from f prime being undefined, because this is always defined, but f prime can be 0. And of course I will divide both sides by 9, so I have cosine x minus sine x equals 0. And it's a nice situation, because cosine x equals sine x, we can divide both sides by cosine, because cosine and sine will not be 0 at the same time. But we know that this happens in only one situation. For pi over 4 here, and for 1, 2, 3, 4, 5 pi over 4 here. Here, sine is positive, cosine is negative, doesn't work. Here, cosine is positive, sine is negative, doesn't work. Here, they are both positive, and here they are both negative. So in the first and the third quadrants. So I have to just create the quadrants here, so I don't, I know where to put them. So I'm going to say that this is pi over 2, this is pi, and this is 3 pi over 2, without really putting them in there, because it's going to crowd my table. So I have pi over 4, and that has to be 0. And I have 5s. Remember, 1, 2, 3, 4, 5. Very easy. You don't have to memorize that. So it's in the third quadrant, so it's right here. 5 pi over 4, and that's 0. Now, in order to find the sign of the derivative, because I'm asked to find increasing, decreasing, so on and so forth, here's the derivative. I will plug in 0 to study the sign to the left of pi over 4. So when I plug in 0, this is 0 and this is 1, so it's positive. Now I'm going to plug in, between these two, I'm going to plug in pi. So this is pi over 2 and this is pi. It doesn't matter. I can plug in pi over 2. For pi over 2, this is 0. For pi over 2, this is 1 with minus, so this would be negative. And at the end, when I plug in 2 pi or 0, it has to be the same. I have to get the same answer, so it's positive. So I don't know how they want the answer, but I already know that this is a local max, positive, negative, but I have to find this value, and I have to find this value. So I will also find a 0. So again, for 0 is 9. So for 0 is 9. For pi, I'm looking at the function. So for pi over 2, both are the same. So f of pi over 2, I have 9. The square root of 2 over 2 plus the square root of 2 over 2. So this is 9 to the square root of 2 over 2, so it's 9 the square root of 2. So this is 9 the square root of 2. I don't know, I didn't approximate, I don't know how they want the answer, but you can approximate if they say you can. Okay, obviously at 2 pi is still 9, and now at 5 pi over 4, they're both negative. Both negative, so it has to be the same number but negative, because I'll have negative the square root of 2 minus the square root of 2, so everything is the same, and this is negative 9 the square root of 2. Okay, so we know that this is a local max, and this is a local min. We know the intervals of increasing. The function is increasing between 0 and pi over 4 union 5 pi over 4 2 pi, and it's decreasing between pi over 4 and 5 pi over 4. Is this okay so far before we move on to the second derivative?
Yes.
Perfect. Okay, so now the second derivative, I differentiate that, and I get negative 9 sine x minus 9 cosine x. When I set this equal to 0, I will get the sine x plus cosine x is 0. Because when I set it equal to 0, I divide both sides by negative 9. So now sine x equals negative cosine x. And I know exactly where that happens. Of course, here and here. At 3 pi over 4 and 11 pi over 4. So this one was at pi over 4 and 5 pi over 4, where both had the same sign. Either both positive or both negative. But here they have to be opposites. Same value, but opposite the square root of 2 over 2, in other words. This is the only angle that does that. Okay, so now that's why I had to have the quadrants, because 3 pi over 4 is right in here, and of course 11 pi over 4 is right in here. 11 pi over 4. So now, of course, we can connect these two, if you remember, with the second derivative test, or not, it doesn't matter. I will plug in 0. When I plug in 0, this is 0, this is 1, so it's negative. So then the function opens downward. Of course, this is an inflection point, and also this is an inflection point, but I didn't find the value yet. I will find the value in a minute. Okay, so now when I plug in exactly in the middle, pi, this will be negative 1, but this will be 0, so negative 1 times negative is positive. I don't have to check 2 pi again, but because 2 pi or 0 are identical. So it holds water and it does not. And I have to determine this value. Back to the function. With 3 pi over 4, this is the square root of 2 over 2. So f of 3 pi over 4 is 9 the square root of 2 over 2. And with 3 pi over 4, this is negative, so it will be 0. And the same thing with 11 pi over 4. Because the sign will be negative 9 the square root of 2 over 2. And this will be positive 9 the square root of 2 over 2, which makes it 0. Very nice problem, thank you. So it's concave down between these two, union 11 pi over 4 to 2 pi. It's concave up between 3 pi over 4 and 11 pi over 4. It has an inflection point at 3 pi over 4 comma 0, another inflection point at 11 pi over 4 comma 0, a local min at this comma negative the square root of 2, and local max at this pi over 4 comma 9 the square root of 2. Again, this was an interesting situation. Thank you for bringing that up. Where's my glass of water? I got it. Any questions? Any questions?
I'm sorry, that was all I had.
Okay, is this clear now?
Oh, yes, yes, for sure.
Perfect. Okay, anything else, anybody? Anything? Well, in that case, we have to finish with section 4.9, entitled Antiderivatives. And first we have to talk about notation. Given, you can say, is it such a big deal? No, but it's important. So given f prime, we're asked to find the antiderivative, and we will have to denote it by f of x. Another possibility is we are given f of x, and we are asked to find the antiderivative, and we will denote it by uppercase f of x. And you can say, what's the big deal? They're all 4 functions. So who cares how you denote them? That's true, but you will see later why in the fundamental theorem of calculus. Okay, so there are 2 major situations here. 2 possibilities. I may be given a function, and we are asked to find the most general antiderivative. We are really asked to find a family of functions. I'll explain with plenty of examples. Number 2, I may be given a function and asked and conditions, initial conditions. And asked to find the unique, the only one, the unique antiderivative. Of course, that satisfies the conditions given. So these are 2 major situations, 2 possibilities. I may be given a function and asked to find all functions that have the specific derivative. I may be given a function which is a derivative in it, or just a simple function, it doesn't matter, we go backwards this time. And initial conditions, in which case we are asked to find the antiderivative. One, because the only one will fill all the given conditions, will fulfill all the given conditions. Okay, so now I'm digging up my book. On page 348, 349, I like to start with any problem, let's say, number 8 caught my eye. And you can choose the next one. On 348. and that is f of x equals x to 3/4 minus 2x raised to the square root of 2 minus 1. Let me see if I copied it correctly. Not that I care, we can make up any function. Yes, 3/4. Is it 3/4? No, it's 3.4. Sorry. So 3.4, they say. I thought I saw a fraction line. Okay. The question is asking us to find the most general antiderivative. Find the most general antiderivative. Okay, so we know that when we differentiate x to the 4th power, we bring down 4 and we subtract 1 from the power. Now, imagine that I am given the acceleration, which is the second derivative of the distance, and I am asked to find the velocity. So it's not a differentiation issue. It's a going back type of issue. It's finding the antiderivative, going backwards. So let's discuss the procedure, and then we'll go back to our function. So then if I want to get x to the nth power, what should I differentiate? What I differentiate is, in the numerator, I have to increase n by 1 and divide by the same number. So if I want to find the antiderivative of this, I will say 4, because a constant is still a constant. What derivative, what function I differentiate to get x to the 3rd is x to the 4th over 4. X to 3 plus 1 over 3 plus 1. Now, if I want to go back and differentiate this, I will get 4 times 4x to the 3rd over 4. These two will go away, and I'm back to 4x cubed. So this is the procedure we have to apply for determining the antiderivative of any of this. So since the function is denoted by lowercase f, we use the notation uppercase F, and we apply twice this procedure, going backwards to find the antiderivative. So x to 3 plus 3 x to 3.4 plus 1 over 3.4 plus 1 minus 2 x to the square root of 2 minus 1 plus 1 over the square root of 2 minus 1 plus 1 plus a constant c. We'll try to simplify it. The denominator is still 4.4. I can't do anything to that. And the numerator is x to 4.4. Now here, these two go away. Since I have this 2 over the square root of 2, I will rationalize by the square root of 2 and the square root of 2 to simplify. And then I get these two again go away, x to the square root of 2 plus a constant c. And this is a family of functions. Infinitely many, because c can be any real number of functions. Called the most general antiderivative. If c is 0, I get a function. If c is 1, I get another function. If c is 100, I get another function, etc., etc. And for the first maybe 1 or 2 examples, since our function is x to 4.4 over 4.4 minus the square root of 2, x the square root of 2 plus a constant c, let's differentiate and make sure that we get this. So f prime should be f of x. Let's check. So f prime of x, I bring down 4.4, x to 4.4 over 4.4, and that's it. Oh, 4.4 minus 1. Minus the square root of 2. I bring down the square root of 2, x to the square root of 2 minus 1. I don't have a denominator. And when I differentiate c, I get 0. So these two go away. I get x to 3.4. This 2 when I multiply, I get 2. And it's x to the square root of 2 minus 1. And this is exactly the function we started with. So just imagine that this was we're going to have examples like that. Let's just imagine that this is the velocity. And we were asked to find the distance function. Or this was the acceleration. We were asked to find the velocity function. Okay, so let's look at more human examples. Like here's 19 on the same page. Same question. So 348. Same question we're asked to find. So this is f of x equals